All right. Sorry I can't be with you. I'm going to talk to you about our hope and plans to support Artemis testing and even robotic missions in the context of Artemis, and crew and other personnel training as well at Haughton Crater. And as Oz pointed out, something I agree with, no single site is sufficient to train astronauts properly for the lunar missions and down the road to Mars as well. But Haughton is an example of one of those places that I think should be part of the palette of sites that are used. This coming year is our 25th anniversary. We've been running this operation up on Devon Island since 1997. So Devon Island is the largest uninhabited island on Earth. It's in the high Arctic, in the territory of Nunavut. We are in a polar desert setting, so there's essentially no vegetation to speak of from an operational impact standpoint. Haughton Crater is the main attraction geologically. It's 20 kilometers in diameter, 23 million years old approximately, and at 75 degrees north. And we are on Central Time Zone, which is Houston's time zone as well, of course. This is Haughton Crater from 10,000 feet of altitude. And from an infrastructure standpoint, we have a permanent base there. In fact, we're one of the few, if not the only, planetary research project that's ever established a permanent base, especially in the polar regions. But we have an airstrip, fuel depots, waste processing helipad, trails, which we've named NASA Road 1 in this case, and our base camp. Our base camp is a collection of modules, each with dedicated functions, labs for astrobiology and geology, garage, core tents that are shared, etc. Now, how is this site really relevant to the moon? Well, for one thing, Haughton happens to be pretty much exactly the same size as Shackleton Crater. It is not as deep. In fact, it's about an order of magnitude less deep than Haughton Crater. There's quite a bit of infilling of Haughton Crater with the impact breccia. But to first order, it's an impact structure of the same size as Shackleton. It presents you with impact rubble. The ground is laced with ground ice, so you're in a permafrost situation, much like in the polar regions of the moon. Solar power is permanent, at least in the summer at Haughton, much like at the lunar South Pole. Comms are horizontal. If you're using geostationary satellites, this summer we'll be using Starlink, but if you're using geostationary satellites for higher bandwidth and more stable links, you will have the similar types of issues, ground effect, multipathing, all of those comms issues that we can encounter at Haughton as well. And of course, we have an outpost there, just like we might be planning one down the road on the moon as well. Topography is relevant. That's the moon on top, Haughton at the bottom. The terrain is in many ways similar, especially inside a Haughton Crater. There are impact ejecta blocks and boulders. There are permanently shadowed regions, even at Haughton Crater. There are valleys that never see the disk of the sun. They are, of course, not in darkness because of scattering in the Earth's atmosphere of sunlight, but nevertheless, they don't receive the brunt of solar shine. And sure enough, these are actually places where we often find patches of perennial ice still preserved, some of which might be thousands of years old, if not dating back to the last glaciation. Impact breccias are a typical rock encountered inside Haughton Crater. Of course, that is a mixture of fragments from the different rock layers that were impacted by the Haughton event. So in that sense, it's a very good way of schooling astronauts in recognizing different lithologies and materials from different depths. Speaking of depth, Haughton Crater, when it formed, bit all the way down to almost a mile of depth into the crystalline basement of Devon Island. And so sure enough, the impact breccia deposits at the surface now include fragments that have come from almost a mile deep here at that location. And so this is, from an operational standpoint at least, a very good analog to looking for South Pole Aitken Basin fragments when we are sifting through the regolith at places like Shackleton Crater around the lunar South Pole. You can train astronauts to recognize deeper seated basement material, essentially, in the impact rubble that you have at the surface. So science operations is what we're going to talk about next. Many parallels with doing ops on the moon, no vegetation in your way. We can use personal vehicles like ATVs to two-seaters to pressurized rovers, simulators. This is a place where NASA has been testing robots for a long while. This summer, we will do more work with Brian Glass, who's leading a field test of the Triton drill that's going to be flown on Viper. We are continuing work with Collins Aerospace, one of NASA's contractors for EVA suit systems. And of course, we have a fleet of mobility vehicles or mobility systems that allow us to range around Haughton crater. So one-person ATVs, two-person side-by-sides, pressurized rover simulators in the form of Humvees, where on the inside we can actually do field research in real time and can set them up with even a temporary lab to analyze rock samples, for example. The vehicles can be equipped and have been with robotic arms, which is of course a good way to operate when you're dealing with a pressurized rover. When you roam around, you don't want to do an EVA every time you see an interesting rock outside. So a robotic arm is a good way of being economical about EVAs. You can also append to the vehicle things like ground penetrating radars, and of course there's ground ice to be mapped everywhere, so that's a very good way of that's probably something we'll be doing on the moon as well as we move forward with Artemis. Vehicular field exploration is really the most distinctive operational attribute of working at Haughton crater. We do geology, drive-by geology, and geology supported by vehicles. In many places, you sort of have to hike in on foot. Here we do on foot work, of course, but usually we get to all our locations and key outcrops to begin with by vehicles, and that's something very characteristic. The beauty of Devon, of course, is that there are no fences, no property lines that are in the way of your being able to plan these long-range traverses over tens of kilometers. So vehicular field exploration training is something that I think we could be uniquely suited to support. We can range across the island, and these are circles showing you the 100-kilometer and 200-kilometer range circles around our site. So this summer, one of the things we'll do, here we've projected the Artemis landing regions boxes onto a map of the same scale of Devon Island, and we plan to do essentially to scout out a traverse that would be commensurate to driving from a landing site at Connecting Ridge all the way to the south pole of the moon, which is represented by the HMP base here in this image. But there are many other traverses that one could plan out and do around Haughton crater as sort of the token South Polar lunar crater. Remote outposts can be set up if we need them. Our base camp itself has a good complement of shelters, of course, but also research gear, lab equipment. We have a greenhouse for forward-looking tests of future greenhouses on the moon and Mars, comm systems, and actually a really good safety record. In the past 25 years, we've had more than 10,000 person days of field operations, only one injury at level 2, which is essentially a broken rib, out of 5 levels that are possible in injuries. And everything else is just really minor stuff. So this over 25 years.
2 minutes, please.
I'll wrap up now. We can do winter ops as well. Actually, NASA has requested a quote from us to support crews and personnel for winter operations. So we hope that this will turn into a reality. We can certainly do that. I'll just leave it at this, but in COVID years, we've been operating in Oregon as well. Thank you for your attention.